Good evening, boys and girls. Welcome to a lesson on Physical Sciences Grade 12. We are definitely preparing for paper 2 that we are going to rewrite on the 17th of December. And Africa Team Geeks, in partnership with the Department of Education, is giving us this opportunity to revise once more and actually do much better in this particular paper, because we are going to rewrite paper 2 for Physical Sciences Grade 12. And that is why I am here with you, and I want to take you through some of the most important aspects that you need to remember as you revise for paper 2 Physical Sciences. I'm going to be sharing quite a number of tips with you on how you can do better in certain sections of this particular paper. For example, we are going for today to deal with organic chemistry, and we will be looking into 3 learning areas of organic chemistry, and that is nomenclature, physical properties, as well as organic reactions. And I want to ensure that by the end of this lesson, you are much better off in answering questions on this section of the work, because that is essentially what these lessons are about. So this is the rewrite lessons for Physical Sciences Grade 12. So let us look at how the lesson is outlined for today. So we are going to have an overview, and we are going to look at organic chemistry as per the examination guidelines. So we are first going to look at what are we required to know in this section of the work, or rather in this topic, which is organic chemistry. What do the examination guidelines tell us we need to know? Because this is going to guide us in actually revising this particular topic, and it will also help you to make sure that as you do your revision, as you study, you are able to tick through your examination guidelines to say, I understand this section of the work, I understand this section of the work, up until everything is ticked under organic chemistry in your examination guidelines. Then you know that you are well on your way to doing well in this topic. Then, in the features of the topic, we will be looking into 3 learning areas of organic chemistry. And in our assignment, we are going to look at questions on organic chemistry, and we will look at questions from previous examination papers. Remember, the idea here, learners, is for us to actually test if we can recall some of the basic things that they ask us, which are recall questions that do not expect us to actually apply our mind a lot. So we need to check on that. So we will be dealing with those type of questions, but we'll also be dealing with questions where we need to apply our mind, where we need to synthesize our knowledge in terms of organic chemistry. So we'll look at questions on different cognitive levels. And when we do these questions as well, this is where I will be showing you some of the common errors and the common mistakes that you as learners actually make when you answer these questions. So we will look at those errors and mistakes, and also omissions that you make in presenting your answer. Remember, my dear learners, when we are dealing with paper 2, it's a content-rich topic. It's also very theoretical, and we need to know how to present our answer in a scientific way, and to ensure that we are able to collect all the marks that are allocated for that particular question. So that is essentially what we are going to look at. And then I will also be giving you some tips as we do these questions to actually see how best you can tackle some of the questions relating to organic chemistry. And when we talk about the topic, lastly, I will be giving you more tips on how to prepare organic chemistry for examination purposes and the mark allocation that you should more or less expect in this particular topic. But just to give you a brief synopsis of the marks, this topic alone counts for 48 up to 60 marks of the question paper. So the minimum will be 48 marks, the maximum can be 60 marks out of 150. So it already tells me that if I do well in organic chemistry, I am well on my way to getting a level 7. But if I don't do well in organic chemistry, then I'm not well on my way to doing well. So this is essentially what the purpose of this lesson is about. So we are quickly going to look at what we are required to know as per the examination guidelines in this particular topic, which is organic chemistry. Now, here's a screen that I have shared for you, and it talks to organic chemistry and it comes from your examination guidelines. So for the first learning area of organic chemistry, we refer to that as nomenclature. Now, under nomenclature, this is a section where we name organic compounds, where we identify organic compounds in terms of their homologous series, which homologous series they belong to. This is a section where we actually identify molecules also using their functional groups to actually assign them to a particular homologous series. This is where we learn the different types of homologous series that you get, meaning the different types of organic compounds that we actually get. So we will have to learn more about that. This is where we also have to learn how to draw, and we will learn how to draw structural formulae, how to draw condensed structural formulae, how to write down molecular formulae as well. So that's what we are going to deal with in this section. Furthermore, my dear learners, in this section, we are going to deal with isomers and the different types of isomers that we get when we are looking at different types of organic molecules. So we will be looking into chain isomers, positional isomers, functional isomers, and so on. So roughly, for you to know this, we are dealing with the organic molecules, their structure, their naming, and the drawing, as well as functional groups. So we have a couple of definitions here in this section, only on nomenclature. But overall, my dear learners, there are quite a lot of definitions that you must know, and they are very easy if you understand the work. Now, the first tip here, my dear learners, is that when we ask you to define any term in physical sciences, both paper 1 and paper 2, we are only going to accept definitions from the examination guidelines. We will not accept any definition from your textbooks as such. if it actually deviates with the definition that we are getting in the examination guidelines. So make sure that all of you have your examination guidelines and you use these examination guidelines to get the definitions that we are going to use when we mark you for your final examination for paper 2. So we must know how to define the term organic molecules. And we know that organic molecules, they are molecules that contain carbon atoms. So you need to know this particular definition. They are molecules containing carbon atoms. So you need to know that definition and you will get it from the examination guidelines. Then we are going to look at different homologous series, and I have highlighted them there for you. Your alkanes, your alkenes, your alkynes, your haloalkanes, your alcohols, your carboxylic acids, your esters, your aldehydes, as well as your ketones. And furthermore, in your haloalkanes and alcohols, remember, we must be able also to distinguish between a primary alcohol, a secondary alcohol, as well as a tertiary alcohol. As well, a primary haloalkane, a secondary haloalkane, and a tertiary haloalkane. We must know how to draw or give examples of these types of haloalkanes and alcohols, and also being able to identify them. Being able to identify an alcohol as being primary or secondary or tertiary, and also being able to give a reason why it is a primary alcohol or a secondary alcohol or a tertiary alcohol. Furthermore, in this particular homologous series, you must then know, my dear learners, how to draw the functional groups of these homologous series. And you must know the name of the functional group of these homologous series. Then, more definitions that we must know is the definition of molecular formula, the definition of a structural formula, and how to define the term hydrocarbon, homologous series, saturated compounds, and unsaturated compound. And with this as well, my dear learners, saturated compound and unsaturated compound, you must know how to define, and you must also be able to identify an organic compound as saturated or unsaturated when you are given a variety of organic molecules. So you must be able to talk about that. So we are just going through a brief overview of what the examination guidelines want us to know, and then we will be able to move into questions. Then, my dear learners, you must know how to define the term functional group. You need to know how to define that particular term. And remember, it is a bond or an atom or a group of atoms that determine the physical and chemical properties of a group of organic compounds. Now, what we definitely know, my dear learners, in simple terms, is that we know a functional group is actually a part of the molecule that we look at, and we can actually use it to identify to which homologous series a particular molecule belongs to. So if you look at the molecule, the functional group tells you to which homologous series does it belong. Does it belong to alkanes? Does it belong to alkenes? Does it belong to alkynes? Does it belong to esters? We look at the functional group. And there it is. You see, with this homologous series, for example, alkanes, this will be the structure of the functional group, because you are going to see it by single bonds between carbon and carbon atoms, and those single bonds between carbon and hydrogen atoms. So when a molecule looks like this and it has hydrogens everywhere, then you know it is an alkane, or it belongs to the homologous series alkanes. When you see a molecule, for example, that looks like this with a C double bond O as well as an OH, which is placed on the first carbon at all times, then you know that this molecule belongs to the homologous series carboxylic acids. This is the structure that you will look for in that molecule. And you are then required to know again the name of this functional group. It's a carboxyl group. Now, my dear learners, remember, we will be asking you questions where we expect you to draw the structure of the functional group of alkanes. And this is what you need to draw. And you need to be able to do that for all the homologous series, and also be able to give the name or a description where it is needed to actually tell us about this functional group. So very important for you to know this, my dear learners. We will definitely ask you. You are not going to get a question where we are not asking you to draw a functional group. Right, so my dear learners, we are definitely going to ask you to draw at least one of the structures of the functional groups of at least any of these homologous series, and we will ask you to give a name of that functional group. Now, as we do questions, you will see I will be showing you some of the mistakes that you make, because other learners cannot distinguish between the structure of a functional group as well as the structure of a molecule. So we will be addressing those particular gaps. Then we are required to know about structural isomers. We need to know how to define it. And we know a structural isomer, those are organic molecules with the same molecular formula, but different structural formulae. Now, my dear learners, if you don't know your definitions well, then you are going to struggle with the content. Remember, you need to know these definitions as they are from the examination guidelines. Furthermore, my dear learners, is that if you take this for granted and you don't revise them, I have seen in many instances where a learner says, structural isomer, those are organic molecules with the same structural formula, but different molecular formula. And that is completely wrong. So know your definitions thoroughly. And we will be looking again at different types of isomers. And we look at 3 types. You must know chain isomers, and we will get those questions. You must know positional isomers. you must know as well functional isomers. So we will deal with these as we deal with questions. And then again, under nomenclature, we must be able to use IUPAC rules to give names to organic molecules when we are given either a structural formulae or a condensed structural formula, as well as a molecular formula as well. And then we will be using those IUPAC rules and we will apply them as we do the questions. But furthermore, you can be given a name of an organic molecule and we will expect you to draw the structure, and that is very important. Right. Then, my dear learners, we are also going to deal with the section on physical properties altogether. Now, when we deal with physical properties, here we must know which physical properties we are actually going to look at. And the physical properties, my dear learners, that we are going to look at are these ones. We will look at the boiling point, we will look at the melting point, and we will look at the vapor pressure. Now, one tip that I can give you, my dear learners, is that there is no way when we give you a question on physical properties, which is normally question 3, we definitely have to ask you one of these definitions. So we will definitely ask you to define either boiling point, or ask you to define either melting point, or ask you to define vapor pressure. There is no way that we can ask you to define any of these, because that's how we begin our questions when we set examination papers for you. We want to see if you actually know and understand these physical properties. So that is the boiling point. We must know how to define it, the melting point, as well as the vapor pressure. Now, for now, my dear learners, I am not necessarily defining that for you. We will be dealing with that as we do questions. We are just going through an overview of what we need to know and understand in this section of the work. Now, all these 3 properties that we are looking at, we must then be able, right, to establish a relationship between boiling point, melting point, and vapor pressure with regards to the strength of intermolecular forces or the chain length altogether, and the types of intermolecular forces that we get as well. We must be able to give a relationship, basically to explain how the strength of intermolecular forces affects the boiling point, the melting point, and the vapor pressure, or how the length of the carbon chain affects the boiling point, the melting point, or the vapor pressure. We must be able to talk about that. Again, we must be able to identify the different types of intermolecular forces that we get in different types of organic molecules. And, you know, that is simply working with the homologous series to which they belong to, or what we call the type of functional group that it has, because that is definitely going to guide you in terms of the type of intermolecular forces that a molecule will have. Now, Don't get overwhelmed. It will get easier as we do questions because we will be reminding ourselves and checking what we actually remember and what we do not remember. Furthermore, my dear learners, we will look into organic reactions. Now, when we look at organic reactions, we are going to look at how alkanes react. We will look at how alkanes react and the type of reactions that alkanes can undergo. And firstly, the type of reaction that we will look at for alkanes is oxidation of alkanes. In other words, the other term that we use is combustion of alkanes. That is when an alkane is burning in the presence of oxygen gas. And even more precisely, we are going to look at reactions where alkanes burn in excess oxygen altogether, right? And that is an oxidation reaction, or what we call a combustion reaction, and we must be able to write it down. In other words, we must be able to write down the reactants. We must then be able to determine the products, and then we must be able to balance that equation. So it's actually a balanced chemical equation when an alkane reacts in excess oxygen. And we must also remember, as recall, that alkanes, we use them as fuels. For example, my dear learners, you know that butane is an alkane, and because it is an alkane, we know that it's one of the alkanes that we will get in cigarette lighters. And because we get it in cigarette lighters and we use it to light up, it means it is being used as a fuel. Again, the gas that we use in our homes during winter for our gas heaters or our gas stoves, it is mainly a lot of propane as well. And that is an alkane. So alkanes are used as fuels. When we look at petrol, petroleum gas and so on, your petroleum fuel, we know, my dear learners, it's a mixture of alkanes and also a lot of hexane in there, and that is why we say we use them as fuel. So that is the recall work. So if a question comes and we ask you, what is the importance of alkanes? Then you must tell us that alkanes are used as fuels altogether, right? Then we are going to look at esterification. Right. Under esterification, my dear learners, we must be able to write down an equation using structural formulae for the formation of an ester. And that is where we will remember that an ester is an organic molecule that is formed from the reaction of an alcohol as well as a carboxylic acid. So you must be able to write down that reaction, have reactants, have products, but also you need to provide the conditions under which that reaction is going to take place. So remember that. We must be able to name the alcohol and the carboxylic acid used and the ester formed. And that is why I was telling you that when you have a molecule which is an ester, you know that it was through the reaction of an alcohol with a carboxylic acid, and it gives you an ester. And those conditions, if you quickly recall them, is that you need sulfuric acid, which will act as a catalyst, and you also need to heat your reaction vessel so that you are able to form that ester. And lastly there, write down the reaction conditions for esterification, which is essentially what I've just told you here. You need sulfuric acid. H2SO4 is the chemical formula, and you need to know the use. So we say it is used as a catalyst, and also you need to provide heat. Furthermore, we will look at substitution reactions, addition reactions, as well as elimination reactions for different types of organic molecules and different homologous series. Furthermore, we need to be able to distinguish between saturated and unsaturated hydrocarbons using bromine water. And I see this is normally a section that learners don't do well in. Half of the learners would get this right, and half of the learners would really not get this one right. So please, we need to take care of that, and I will give you more questions on this section of the work. And lastly, under your examination guidelines, remember, we still need to know about plastics and polymers. These things apply in our real life because we use polymers. They are produced by big companies in South Africa. One of those companies is Safripol. So it's things that we use in our daily lives and we need to know about them. And hence they form part of organic chemistry. Now, you must be able to describe the following terms: macromolecule, polymer, a monomer, polymerization. Now, here, my dear learners, there is no way that we will start questions on polymers and not ask you to give us a definition of any of the following: macromolecule, polymer, monomer, or polymerization. You need to know that. And we will be learning how to form polymers. And to form a polymer, you actually perform a reaction that we call polymerization. And hence we need to know how to define the term polymerization. And we will also then be able to distinguish or give the difference between addition polymerization as well as condensation polymerization. Are we together? Right. So we will have to be able to differentiate between all of those, and also an addition polymer as well as a condensation polymer, and also condensation polymerization altogether. And we must then, when we look at polymerization, be able to identify monomers from given addition polymers. We must be able to write down an equation for the polymerization of ethene to produce polyethylene, and be able to state the industrial uses of polyethylene. Are we together? So, my dear learners, this is essentially what we need to know in terms of examination guidelines. Now, why did I go through this with you? Because it should give you an idea of what you know and what you do not know, what you understand better and what you don't understand better. Now, how do we use these examination guidelines when you prepare for your examination, my dear learners? You can see everything is written in a bullet form. When you have started to revise, you see there I have a bullet that says define organic molecules as molecules containing carbon atoms. When you are certain that you know how to define this, then you tick the bullet, then you know that you are actually starting to do well altogether, because you know what the examination guidelines want you to know. And if you are well prepared, it means all these ticks at the end of the day, before you go and you write your examination, they are going to be ticked. And if you can do this, I'm definitely guaranteeing you that you are going to get a level 7. Are we together? Right. Now, we go straight into questions. Now, my dear learners, remember, the idea for us to conduct these revision lessons is actually to also make you work so that you check what you know and what you do not know. So here, I'm going to give you a question and I'm going to allocate you time for you to do this question. And after that time that I have allocated for you is done, then we are going to answer this particular question altogether. So I want to also check that you are able to answer these questions so that when I correct you, you can check if you have made mistakes or if you were able to obtain the mark as they are. And it is the prayer of my heart that you will be able to answer these questions, and then we will all be able to do well. It will not really serve a big purpose or the ultimate purpose if what I will do is just to give you the answer. So I want us to work together. So here is a question. It is 4 marks. I am definitely going to give you 4 minutes. According to my time, it's 8:17. So 8:22 exactly, I will be giving you, in fact, we will be discussing this and actually see what we need to know and where are the mistakes that you could have made and so on. Right, so your 4 minutes starts now. Right, my dear learners, I want to believe that I gave you sufficient time to be able to answer this particular question. In the interest of time, my dear learners, we will actually just answer these questions that I have prepared here for you together, but please take time to actually answer them on your own as well, and to make sure that you are really, really thoroughly prepared for these particular lessons. Right, now, the IUPAC name of an organic compound is 4,4 dimethyl pent 2-ine. Then they ask us to write down the general formula of the homologous series to which this compound belongs. Now, for us to be able to write down the general formula, my dear learners, remember, I must first know where this organic compound belongs to. In other words, I must know the homologous series. When I know the homologous series of this molecule, then I will be able to give the general formula of this particular molecule. Now, this molecule, I can see it's a pent 2-ine. So the name of this molecule ends with YNE. So this tells me that this molecule belongs to the homologous series alkynes. Now, if the molecule belongs to the homologous series alkynes, I will then know that The general formula of alkynes is CnH2n minus 2. Are we together? Right, it's CnH2n minus 2. And everything has to be correct for you to get a mark. Are we together? So you can't have anything that is wrong there. And again, my dear learners, remember the n there, the 2n minus 2, they must be a subscript. And the n is on the C, the 2n minus 2 is on the H. Then we are required to write down the structural formula of this compound. So now we must know how to interpret this name first for us to be able to write down the structural formula. And we can see that this is going to give us 3 marks. Now, these are a lot of marks and we should not lose this particular marks. Now, to draw the structural formula of this compound, let us first analyze the name. Now, when we analyze the name, definitely we have seen because of the YNE, it means this molecule is an alkyne. It belongs to the homologous series alkynes. Now, if it belongs to the homologous series alkynes, we know that with alkynes, you are going to get a triple bond between carbon and carbon atoms. It's not just a triple bond, it is a triple bond between carbon and carbon atoms, and only between 2 carbon atoms for your syllabus altogether. Right, so it means somewhere I must have a triple bond. Then we look at the 2. The 2 there, we know that it gives me the position of the triple bond. Altogether, it gives me the position of the triple bond. It means the triple bond must be on carbon 2. And if it is on carbon 2, it basically tells me that I will get it between carbon 2 and carbon 3. So remember, the 2 gives the position of the triple bond. And we know that triple bond is actually the functional group. Can you see, my dear learners, how we can actually use these questions to actually revise a lot of things? Then the pent tells me that I have 5 carbons, but not just 5 carbons. It means I have 5 carbons where? In the parent chain. Not 5 carbons in the entire molecule, 5 carbons in the parent chain. Why are we saying it's 5 carbons in the parent chain? Because pent means 5, just like pentagon, it's a shape with 5 sides. Now, why are we saying in the parent chain? Because when you give an IUPAC name, we know that the pent 2-ine is the parent chain, the longest chain of carbon atoms without breaking. Then what comes before the parent chain, we refer to that as substituent. Now, my substituent there, it says di, right? Di means I have 2 of the same substituent, and that 2 is 2-methyl substituent. So I have 2 methyl substituents altogether, and that is why we say it's dimethyl. And then what does the 4 tell us? It tells me that 1 methyl is on carbon 4 and the other methyl is on carbon 4. That is why I have dimethyl 1 is going to be on carbon number 4, and the other methyl is also going to be on carbon number 4 altogether. When you have analyzed the name, then you go, my dear learners, and you actually draw the molecule. Now, we know they are saying it must be a structural formulae. It means all the atoms must be shown as well as the bonds. And we know when we draw a structural formula, we always start with the parent chain and we end with the substituent. It's like the parents, we start with them and the children come afterwards. So the parent chain has 5 carbons. Then I will draw 1, 2, 3, 4, 5. So now I'm done with the part of the pent altogether because it's 5 carbons. Then I go, remember it's a pentyne, so I have a triple bond and it must be on carbon number 2. So if you are counting from left to right, you say this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Then on carbon 2, you are going to put the triple bond altogether. So it's 1, 2, 3. So now you are happy with the pent, 5 carbons, YNE, triple bond 2. The triple bond is on carbon number 2. Then you go to your substituents. Your substituent is a methyl on carbon 4 and another methyl on carbon 4 because it's dimethyl. So we said this is carbon 1, carbon 2, carbon 3, so this will be carbon 4. So on carbon 4, I'm going to put a methyl. Now, meth, what does meth mean? It means 1 carbon atom. So it will be a carbon atom. And if it's a methyl, it means it's actually a substituent. So it's actually short of 1 hydrogen. So it's a CH3. Then again on carbon 4, I have a methyl. So it will be CH3. Now, my dear learners, we have seen that this molecule belongs to the homologous series alkynes, and therefore it is a hydrocarbon. So it's a molecule that contains only carbon and hydrogen atoms. It means the only thing that is left here is to make sure that around each carbon atom I have 4 bonds. Remember, carbon makes 4 bonds. So let's go to carbon 1. Carbon 1, I have 1 bond. So I'll have the second bond, the third bond, and the 4th bond. And then on those bonds, immediately I will put my hydrogens. Now, my dear learners, refrain from actually putting the hydrogens afterwards because you forget them and you end up making mistakes. Let us look at the second carbon. It has 1, it has 2, it has 3, it has 4. So this one, I can't put anything because this carbon already has 4 bonds. Let's go to the third carbon. The third carbon has 1, 2, 3, and there it's 4. So I can't put any other bond on the third carbon. Then I go to the 4th carbon. On the 4th carbon, it has 1, 2, 3, 4 bonds. So I'm happy with this carbon altogether. Then the 5th carbon, it has 1 bond. So I need to make it 4. It will be 2, 3, 4. And I'm going to put my hydrogens. There we go. There are my hydrogens. Then I still need to double check these carbons, which are my substituents. This carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. Then my molecule is correct. So the first mark is definitely for the functional group being present and being at the correct position, and where the functional group is, each carbon has 4 bonds. If that is not the case, you will still not get a mark for the triple bond, because the carbons that are having the functional group, you need to make sure that around them, that carbon has 4 bonds. So if I were to show the triple bond, but now this carbon doesn't have the 4th bond and this carbon doesn't have the 4th bond, then I will forfeit the mark. And those are the mistakes that some of the learners are committing, and you don't get marks. Then the second mark is definitely for both substituents being present and being at the correct position. And the last mark is definitely for the entire structure being correct. And that is how you would easily get your 4 marks. Right, we continue. Right, my dear learners, remember I said to you, when we deal with these questions, I also want you to answer them with me altogether, so that we are actually working together and you are able to see the corrections that I am actually giving you. So here is the question. The organic compound below has 1 positional isomer and 1 functional isomer. Right. Now, when you see that statement, my dear learners, you must already be thinking about what is an isomer, firstly, or what is a structural isomer, and also be thinking about what is a positional isomer and a functional isomer, and what are the differences altogether. Now, we are required to define the term positional isomer. Now, when we define the term positional isomer, we know positional isomers are organic molecules with the same molecular formula, organic molecules with the same molecular formula. But now, my dear learners, remember, it's a positional isomer altogether. So when it's a positional isomer, now it is specific. I know that when we define just isomer or structural isomer, we say those are organic molecules with the same molecular formula but different structural formula. But for this one, my dear learners, they want you to be specific about a positional isomer. And you know, for a positional isomer, my dear learners, it means the position of the functional group is going to change altogether. The position of the functional group is going to change. So please make sure that you know that, and it must be very clear altogether. So those are organic molecules with the same molecular formula, but a different position of the functional group. Organic molecules with the same molecular formula, but different position, of the functional group. So the functional group must now be at a different position. Now, my dear learners, when we deal with functional isomers, you don't change the functional group. You just place the functional group at a different position. So how do we mark this one? You just get a different color there. Organic molecules with the same molecular formula. That will be one mark, but different position of the functional group. That will be another mark. Now, my dear learners, the trend now is actually that we are actually moving into a direction where definitions are 2 marks or 0. So everything has to be correct in order for you to get all the marks. So it is not always, my learners, that it's going to be part marked for saying the first part will be a mark, the second part will be a mark. Note the definitions correctly. Now, what are the mistakes that you are doing? Some of the learners, they omit organic molecules. They will just write same molecular formula, but different position of the functional group. What has the same molecular formula? You are not making it clear. So you write in full. Organic molecules with the same molecular formula, but different position of the functional group. Now, they say, for this compound, write down the IUPAC name of its positional isomer. Now, let us look at this molecule. Firstly, this molecule, you will say to me that, Menier, it definitely belongs to the homologous series ketones. Why does it belong to the homologous series ketone? Because the learner can see the functional group there. And what is the name of the functional group? We say this is a carbonyl group between 2 carbon atoms. That's how you write it in full. It's a carbonyl group. There we see it between 2 carbon atoms. When that carbonyl group is in that position, then this molecule, we refer to it as a ketone altogether. Now, according to IUPAC rules, or let me put it this way, let us actually try and give a name to this organic molecule. Now, it is a ketone, so the name is going to end with ONE altogether. And the molecule is definitely going to start with the part of the parent chain that has the longest chain without breaking. So if I count the number of carbon atoms, I will say this is carbon 1, carbon 2, carbon 3, carbon 4, and this one is carbon 5. Why did I number from left to right? Because according to IUPAC rules, the functional group takes priority and it must be on the lowest numbered carbon. So if I number from left to right, then this carbonyl group, which is the functional group, is on carbon 2. So it's correct. But if I had numbered from right to left and said 1, 2, 3, 4, 5, then this carbonyl group would have been on carbon 4, which is wrong because it disagrees in that case with the fact that the functional group must be on the lowest numbered carbon. So I have numbered correctly. Now, my dear learners, how do we give a name to this one? I look for the parent chain, the longest chain of carbon atoms without breaking. It's carbon 1, bonded to another carbon, no break, to another carbon, no breaking in the bond, another one, so it's 5. So it's a pentan altogether. It's a pentan altogether. Now, most of you, you know that 5 means pent, right? But remember, you must have that AN because that's how we name them. So it's a pentan. And I said to you, the name is going to end with ONE because it's a ketone. So the name must end with ONE. And this tells me that this is how the name begins. This is how the name ends. So between there, you need to give the position of the functional group. That is what IUPAC rules say. So to give the position of the functional group, we can see that the functional group is on carbon number 2, right? It's on carbon number 2. Now, are we done? And the answer is no. Remember, according to IUPAC rules, you must have a hyphen between a letter and a number. So I will put a hyphen there. Again, a letter and a number, so I must put a hyphen there. So this name or the IUPAC name of this organic molecule is pentantuone, and I don't have any substituents. Why? Because all of the carbons there were counted on the parent chain. Now, if I want a positional isomer, the IUPAC name of the positional isomer, my dear learners. Obviously now, it means the functional group there cannot be on position 2. It has to be at a different position. For example, we can put it on position 3. Now, let us actually just draw the molecule before we actually give it its IUPAC name so that we are able to practice. So remember, a positional isomer, it must still have the same molecular formula. So the number of carbon atoms must still be the same. So it will be 1, 2, 3, 4, 5. Remember, what should change is the position of the functional group. It's not the functional group. So in the first instance, the functional group was on carbon 2. So if I want to make a positional isomer, I need to put that functional group at a different position. And let us say I put it now on carbon number 3. Okay, that one does not look nice. Right there, let's make it look nice. There we go. All together. Now, how do I know this is position 3? Because if I number from left to right, it's 1, 2, 3, 4, 5. If I number from right to left still, it will be 1, 2, 3, 4, 5. So this will still be on carbon number 3. And all that is left is to now check that around each carbon I have 4 bonds. So here is 1, 2, 3, 4. I put my hydrogens. On this one, it's 1, 2, and then 3, the 4th bond. Then on this one, it's C double bond also. It's 1, 2, 3, 4. So I put nothing. On this carbon, it's 1, 2 bonds. So this will be the 3rd one, and this will be the 4th one. Right? Then on carbon number 5, there is 1 bond. So I'll put another one, the 2nd one, the 3rd one, and the 4th one all together. Then this one is definitely a positional isomer. Let us check. For it to be a positional isomer, we said these 2 organic molecules, they must have the same molecular formula, and let us check if that is the case. The number of carbon atoms here is 5, so the molecular formula is C5. The hydrogens is definitely 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. and the oxygen is 1. And I can guarantee you again, my dear learners, that it is the same here. It will be C5H10O. So it already qualifies that the molecular formulae of these two are the same. But what about the position of the functional group? Can you see now that carbonyl group, which is the functional group between two carbon atoms? You can definitely see that it is now on position 3. So what will be the name? Can you see it's a positional isomer? So they were looking for the name of that molecule. The name of that molecule is definitely going to be the number of carbon atoms. It's 5. So we know then it will start with pent. So it's a pent. And you know when we call it, we say it's a pentan. And this is still a ketone. So the functional group did not change altogether. It's only the position. So the name will still end with O-N-E. So this is how the name begins. This is how the name ends. What must go between that is the position of the functional group, which is 3 altogether. Am I done? No. According to IUPAC rules, I need to have a hyphen between a letter and a number. There it is. Am I done? No. There's a letter, there's a number, so I need to have a hyphen. So the name of this molecule is pentan 3-one, and you are going to get 2 marks altogether. The first mark is actually for identifying that it's a pentanone. That will be 1 mark. The second mark is actually for giving the correct position of the functional group together with the hyphens between the letters and the numbers, and basically to just say the whole molecule being correct. And for 2.2.3, we are required to give the structural formula of its functional isomer. So we must give now the functional isomer of this molecule. So this one was the positional isomer. Positional isomer. So now we must give the functional isomer. So here we are going to draw the functional isomer, which is the structure that they are looking for. That is question 2.2.3. Now, before you can draw the structural formula, remember, these are structural formula. You must show us the atoms and the bonds. And it must be a functional isomer. So you quickly need to revert back and ask yourself, what is a functional isomer firstly? Because you can't draw a functional isomer if you don't know what it is or define it altogether. Now, by definition, a functional isomer or functional isomers are organic molecules with the same molecular formula, but different functional groups. So it has different functional groups, and we are not answering. Remember, here we are just reminding each other. It has different functional groups and the same molecular formula, right? So if I want to draw the isomer of this one, the functional isomer of this molecule, then I need to make sure that firstly, whatever I draw here will have the same molecular formula as this one. In other words, if it must have the same molecular formula as this one, it means the functional isomer must also be a C5H10O. That is the first thing that you need to remember. but the functional groups must be the same. It means this carbonyl group, my dear learners, I cannot get it between two other carbon atoms. That is what is not going to happen when I draw a functional isomer. Because if I were to draw it again between two other carbon atoms, my dear learners, then it will still be a ketone. The functional group will still be the same. So then it wouldn't be a functional isomer. So it means it must be a completely different functional group. Now, how do we recall this one? You see, when you want to draw a functional isomer of a ketone, you must draw an aldehyde. So, with ketones, and you want a functional isomer, it has to be an aldehyde. And it goes the other way around. If I was given an aldehyde and I must give a functional isomer, then I must give a ketone. The functional isomer will be a ketone. So from having a ketone to drawing an aldehyde, it means the aldehyde will be the functional isomer altogether, because the functional group of aldehyde is not the same as that of the ketones. With aldehyde, we have what we call a formyl group, or we say it's a carbonyl group on the first carbon altogether. So with aldehydes, remember I said the molecular formula must still be the same, so it must still be 5 carbons. 1, 2, 3, 4, 5. Now, if the functional isomer of a ketone is an aldehyde, I know on the first carbon, and the first carbon, it can be on the left-hand side, right? Or on the right-hand side. So I will just draw it on the right-hand side. So this is my first carbon. Why? It's carrying the functional group. And it's a carbonyl group on the first carbon. That is an aldehyde. Then I check the bonds. I see it's 1, 2, 3 on this carbon. So I give the fourth bond with the hydrogen. On this one, it's 1, 2. So I make it 3. And then I make it 4. On this carbon, it's 1, 2. I make it 3. I make it the fourth bond. This carbon, it's 1, 2. So here is the third bond. And here is the fourth bond. And then on this carbon, I have 1 bond, so I'm short of 3. So the second bond, the third bond, and then the fourth bond. Then this molecule is correct because I double checked everything. And we can still double check carbons, 1, 2, 3, 4, 5. Happy with that. Hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Happy with that. Oxygen. So can you see, my dear learners, the molecular formula is the same. So the first part, we are happy with it. Then, is the functional groups different? Yes. This functional group is different to that functional group. This is the carbonyl group between 2 carbon atoms. This is the carbonyl group on the first carbon atom. So you will firstly get a mark there for the correct functional group only when around the functional group you have 4 bonds. If you don't have 4 bonds, you will forfeit the mark. And the last mark will be for everything being correct. So I'm really hoping that, my dear learners, you will get all the marks in terms of this. Apply your mind. Right, we move on to the next question. Now, they say to us, consider the condensed structural formula of an organic compound below. So it is a condensed structural formula, and I hope you know what we are talking about. Remember, with a condensed structural formula, we are not going to show the bonds between the carbons and the hydrogens altogether. So that is what a condensed structural formula is. It's really a short way of writing down an organic molecule. So here it is. My dear learners, I know for a fact that 70% of the learners are unable to work with organic molecules when they are written in condensed structural formulae. And that is why you are allowed to do some rough work, even on your answer book. So my first tip here is to say, when you have been given this type of a molecule, before you even go and answer, turn it into a structural formula, which is not condensed, so that you are able to see exactly what this molecule is, you are able to name it. Otherwise, when it is like this, my dear learners, it will become very difficult for some of you to actually work with it. This one is a little bit easier in terms of seeing there the OH, right? That OH group. I also hope you remember what it is. We know it's a hydroxyl group. That is the functional group of alcohols. In other words, here I'm looking at an alcohol. So before we go further, let us draw the structural formula of this molecule and not work with it in a condensed form. So this carbon there that I'm looking at, they are showing me that it has 3 hydrogens. So I will write 1, 2, 3. So I will put the 3 hydrogens. Then this carbon there, it has 2 hydrogens. So it means it bonds to this carbon and then it will have 2 hydrogens. And then this carbon, there it is. Again, it is bonded to a hydroxyl group. So it is bonded to OH. Now, another tip, if I were required to draw this, remember, it must be the oxygen that bonds to the carbon and the hydrogen that bonds to the oxygen. You can't have the hydrogen bonding to the carbon. Are we together? Right. Then I can see again on this carbon, I have a CH3 as a substituent. Even if you don't see that it's a substituent, but you can definitely see that, oh, there I must have a CH3. So I'll have a C, and this C has 3 H's, so it will be 1, it will be 2, and it will be 3. Are we together? Right. Then this carbon must then be bonding to this one. Can you see that? Right. So when you turn it into a structural formula, it will be very clear that, oh, there is no way that this carbon could have bonded to this one because this one is already full with 4 bonds. So this carbon must be bonding with that one, and it will have 3 hydrogens. And the molecule is correct. All carbons have 4 bonds. Then they ask us, number 1, is this a primary, secondary, or tertiary alcohol? And they say give a reason for the answer, and that is 2 marks. So the first mark, it will be for identifying any of those. The second mark will be for the reason. Now, if you want to check if a molecule is primary, secondary, or tertiary, what you will do is, because it's an alcohol, you are going to focus on the hydroxyl group, which is the functional group. There is the OH. And this OH is bonded to this carbon. Now, can you see that the carbon that is carrying the functional group is bonded to how many carbons? It is bonded to this carbon. It is bonded to this carbon. It is bonded to this carbon. So the carbon there that is carrying the OH is bonded to how many carbons? This carbon is bonded to 1, 2, 3. So if it is bonded to 3 carbon atoms, then it will be tertiary. Then I will get a mark. What is the reason? And please write this in full and correctly. The reason is the carbon, this carbon here, this carbon carrying the hydroxyl group, the carbon carrying the hydroxyl group, in other words, the OH is bonded to 3 carbon atoms. So you will say the carbon which is carrying the hydroxyl group is bonded to 1, 2, 3 carbons, and therefore it's tertiary. If it was secondary, then it means the carbon carrying the hydroxyl group is bonded to 2 carbon atoms. And then if it was, this one was bonded to 1 carbon, then you would say it is a primary alcohol. Then the reason would be the carbon carrying the hydroxyl group, that is a key word, is bonded to 3 other carbon atoms. And there you will get 2 marks. The first mark is there, the next mark is there. So if anything is omitted in the correct, any keyword that is omitted which gives meaning to this explanation or this reasoning, then you will not get a mark. Then we are required to write down the IUPAC name of the above compound. Now, if we want the IUPAC name, you must remember that we have to do what? To apply IUPAC rules. Now, to give a name to this compound, firstly, you will check to which homologous series does it belong. And this one is definitely an alcohol. Altogether, my dear learners, this is definitely an alcohol. Now, if this is an alcohol, my dear learners, then I know the name ends with OL. The name will end with OL. Are we together, my dear learners? And obviously, the name, what it begins with, depends on what? The parent chain, the longest chain of carbon atoms without breaking. All together. So let us look for the parent chain. Right. Going to do this. Remove a couple of things there to make our structure neat. Right. Let us check here. What is the longest chain of carbon atoms without breaking? It's carbon, there's no break. 1, 2, 3, 4 carbons. If you go this way, it's 1, 2, 3, 4 carbons. If you go this way, it's 1, 2, 3, 4 carbons. If you go this way, it's 1, 2, 3, 4 carbons. If you go this way, it's 1, 2, 3 carbons. If you go this way, it's 1, 2, 3 carbons. So the longest chain of carbons without breaking is definitely 4 carbons. And if it is 4, we know that is definitely a bute. Are we together? And because it's a bute, we say we must add our AN, so it will then begin with butane. Then, because it is an alcohol, I see the hydroxyl group there. I know that it must end with OL. All together. Now, what are we supposed to do again? Remember, we must give the position of the functional group. Now, to give the position, we have to number correctly. Let us number the parent chain. For me, it's definitely from right to left. It's 1, it's 2, it's 3, it's 4. Why is that the case? Because if I number from right to left, then this hydroxyl group, which is the functional group, is going to be on carbon number 2. But if I were to number from left to right, it would be wrong, because then it would be 1, 2, 3, 4. So this hydroxyl group will be on carbon 3. And we know, according to IUPAC rules, the functional group must be on the lowest numbered carbon. All together, my dear learners. As a result, this is the correct way to number it. Another learner could have numbered from there and said 1, 2, 3, 4 will still get the same answer. So I can see that in my parent chain, which is this one, the hydroxyl group is on carbon 2. So between what it begins with and what it ends with, I'm going to put a 2. Now, what is the other IUPAC rules? There must be a hyphen between a letter and a number. So I'll put a hyphen there, a letter and a number, I'll put a hyphen. Now the question is, am I done with this molecule? And the answer is no, I am not done with this molecule. Why am I not done with this particular molecule, my dear learners? This is for one reason. I did not count that part of the molecule altogether. So that carbon there did not form part of the parent chain. That is why it is not numbered. So it means that is a substituent. And it is a substituent with only one carbon. So that substituent is definitely a methyl. Why methyl? Because meth is for one carbon. And why yl? Because we are actually short of one hydrogen. It's not a methane, it's a methyl. Again, this substituent, can you see it's also on position 2? So I need to give the position of the substituent according to IUPAC rules. And the position is that this methyl group is on carbon number 2. Now, as we can see that it's on carbon number 2, then we say other rule is that between a letter and a number, I need to have a hyphen. So this is going to be called 2-methyl butanol. So this will be the name of the molecule. Are we together? Then the last question for the day. We must write down the IUPAC name of what? The major organic product formed when this compound undergoes an elimination reaction. Right. Now, my dear learners, we are going to do 2.2.3 here. Now, we are not yet answering the question. I will give you the part when we are answering the question. This is what I want us to look at. It will be better for you to understand how to determine this organic product if you definitely know how to perform this elimination reaction. If you can't perform the elimination reaction, my dear learners, then you are not going to be able to actually determine the organic product, and henceforth to give it a name. Now, I need to tell you upfront, my dear learners, you cannot give an IUPAC name to a product that you do not know. It means you must first have the structure of this major organic product. And when you have the structure of the major organic product, then you will be able to then give us the IUPAC name altogether. So this is what you need to understand. Now, once we say we want a major organic product, it means something must kick in your head, my dear learners, that there are probably two possibilities of products: the minor product and the major product. And we know by definition, the minor product is the product that is not going to form. And that is why we never really ask you to draw the minor product, because that is the product that is not going to form. But the major product is the product that is going to form. And that is why we want you to give us the structure of the IUPAC name of the major product. And because now you have to determine the major product, it means you need to apply the rule for elimination, because they are telling us that this molecule will be undergoing elimination. So we must apply the rule for elimination. And I'm going to sum it up for you, or perhaps call it a recipe. When we deal with elimination, my dear learners, it means firstly, we are removing something altogether. We are removing. So when this molecule is undergoing elimination, it means there must be something that we remove. And we must remove the functional group. And when we remove the functional group, my dear learners, it means this carbon is going to be short of bonds. Now, when this carbon is short of bonds, after removing the OH, which is the functional group, my dear learners, it means to make the product look correct, I have to introduce a double bond. And when I start to introduce a double bond, either this side or this side, I will then have to remove a hydrogen, because if the double bond comes this side, it means this carbon would have 5 bonds, so I'll have to remove the H. If I were to bring the double bond this side, then I'd have to remove the H there. And that is why where we will put the double bond when we perform elimination is very important, because we have two possibilities. And one possibility is that of the minor product, which is the product that is not going to form. The other one is the correct one, which is the major product, the product that is actually going to form. Now, because there are two possibilities of introducing a double bond, either this side or this side when the OH is removed, then we must apply the rule for elimination. And I want to put it easily to you, and I will just say H removed from less. And Menier, what do you mean when you say H removed from less? This is what you will do. Let us perform that reaction, which is not what they asked us, but we want to understand better. There I have my 2-methyl butane 2-ol, which is this product undergoing elimination. See, it's also a nice revision of reactions, organic reactions. Right, so it undergoes elimination altogether. If you want an alcohol, this one to undergo elimination, definitely you need to provide heat and sulfuric acid as a catalyst. These are what we call reaction conditions. Now, this is what I want you to see. When you perform elimination, you are going to remove the functional group. Remember, okay, that's not nice. There we go. When you perform an elimination reaction, you are eliminating, you are removing. So the first thing that you must know is that the functional group must be removed. So you will remove this functional group. Now let us draw the organic product then after we remove this OH. And I'm taking you step by step here. I will still have the 4 carbons there. 1, 2, 3, 4. And then I will still have that C there with H and H as well as an H. Now, when I remove the OH, my dear learners, can you see that this carbon now, which had the OH, this carbon which had the OH, this one, now it doesn't have the OH anymore. So now the molecule looks wrong because it's now 1, 2, 3 bonds around this carbon. So to fix this, I will have to put a double bond on this carbon. Now, if I bring a double bond on this carbon, in other words, if I bring a double bond there, I will have to remove that H. Can you see by putting a double bond there, this H will have to go. It means I would have removed this H from where? From this carbon, which has 2 hydrogens. Then, if I decide that the double bond must come this side, it must go there. Meaning, if after removing the OH, I want the double bond to go there, means I'll have to remove that H. So this H would be coming from a carbon that has 3 hydrogens. So if I bring the double bond this side, I remove the H from a carbon that had 2 hydrogens. If I bring a double bond this side, I will have to remove the H from a carbon that had 3 hydrogens. So according to the rule for elimination, the hydrogen must be removed from less, meaning from a carbon that already has less hydrogens. In other words, after removing this OH, I would have to put a double bond this side so that I can remove this H because it's from a carbon that had 2 hydrogens, and not a double bond there because I will have to remove from this H, which is from a carbon that had 3 hydrogens, so it would be more. So that would not be with regards to the rules. As a result, according to the rule of elimination, it means the double bond must come there. Are we together? When the double bond comes there, it means this carbon now has 1, 2, 3, 4 bonds. This hydrogen that was there, okay, it's still there, but this hydrogen that was here is removed. This one still has 3 hydrogens. We did not affect anything there. Are we together? This carbon, we didn't affect anything. It still has 3 hydrogens. And what did you remove? You remove the OH there. You also remove that H. So this will be plus H2O. This is if you were asked to write a fully balanced chemical equation, and this would be something like 5 marks. So this product here, my dear learners, this product here that we have formed, this product is the product that is organic. Remember, we want the IUPAC name of the major organic product. This product, it's not organic. So the one that is organic is this one because it contains carbon atoms. So we must give the IUPAC name of that one altogether. So they didn't ask all of this. They didn't want any of this, but you needed to have that structure for you to be able to give a name of this major organic product. So to give a name, I must first number the carbon atoms. Let me use a different pen. Remember, the functional group is that double bond there, which must be on the lowest numbered carbon. So if I number from right to left, right, it would be 1, 2, 3, 4. The longest chain without breaking. That one can't be part of it because it breaks. So the longest chain without breaking, it's 4 altogether, which is a bute. And I have a double bond. So if a double bond is there, I know it's an alkene, so the name must end with ENE. Again, my dear learners, when you are giving an IUPAC name, remember the functional group must be part of the parent chain. And that is why it is part of the parent chain. So what else is left here, my dear learners, is to give, I know it begins with bute, it ends with ENE, then I need to give them the position of the functional group, which is the double bond, and I can see it on carbon 2. And please do not be confused because some can see it's between carbon 2 and 3. The lowest number is then 2. So we'll put a 2 there, hyphen between a letter and a number, hyphen between a letter and a number. Bute 2 in. Then we say, oh, there we have a substituent there which we did not count. And this substituent is on carbon 2. It has 1 carbon and 3 hydrogens, so it must be a methyl. It must be a methyl. And you need to tell us where it is, and it is on carbon number 2. And we must have a hyphen between a letter and a number. So the name of this major organic product, which is the answer to this question, it's 2-methyl bute 2-ene. Now, what if I numbered from left to right and I said 1, 2, 3, 4? Can you see if I said 1, 2, 3, 4? This would be carbon 2, so it will still be a bute 2-ene. But now this substituent will be on carbon 3, so it will give you 3-methyl bute 2-ene. And remember, according to IUPAC rules, you need to ensure that also the substituent becomes on the lowest numbered carbon. However, we still remember that the functional group is more important than the substituent altogether. And this is all I had for you for today, to panel beat nomenclature and show you how you need to get to the answers and how you should actually study. Because with this, you would have seen that we revised a lot of things, definitions, and so on. And that's essentially how you should study. Don't just answer the question. Use these questions as a tool to study and to check what you remember. So this is all I had for you for today. For tomorrow, my dear learners, we are then going to look at questions on physical properties and move further into organic reactions altogether. So A couple of tips that I would just love to give you. It's this final examination that you're going to rewrite. The section on nomenclature only will be plus minus 20 marks, what we have worked with, because for this question, for example, you have seen it's 16 marks. The other 4 marks is definitely in the multiple choice questions, and you can definitely totalize this. We want you to get all the marks altogether, and I've already given you more tips on how to approach these particular questions. I would love to leave you with a saying by our famous scientist, Albert Einstein, that said, once you stop learning, you start dying. So appreciate every moment when you are studying, because you are learning, and therefore mentally you do not die. Now, send me more questions to stemdigitalschool@africateamgeeks.co.za. stemdigitalschool@africateamgeeks.co.za, and this is a platform where I will get your questions and I will be able to answer them together with you, and you will be able to learn more, because I will also be addressing some of the content challenges that you have. So I'm urging you to really send me more questions to that. So that is me signing out, Mr. Sibanyoni. It was such a great pleasure to have you here, and I hope that you have really, really learned something. Thank you so much. Go and practice with more question papers and your examination guidelines, and you are well on your way to getting a level 7. Thank you so much for joining me, and enjoy the rest of the evening. Good night.